The definition of structural components under Section 760.6 of the National Electrical Code refers to parts of a building that are essential to the stability of the building or to the support of floors, roofs, walls, ceilings, or other loads. Structural components include items such as columns, beams, arches, trusses, floor joists, ceiling joists, rafters, studs, wall plates, and other load-bearing members. Alarm cable is not considered a structural component as defined by the National Electrical Code. Therefore, according to the information given, it is permissible to strap alarm cable to sprinkler piping above a suspended ceiling. This allowance is based on the fact that the alarm cable itself is not essential for the building's stability or the support of any loads. While the sprinkler piping might be considered a structural component due to its role in the building's fire suppression system and potentially its support structure, the attachment of the low-voltage alarm cable does not compromise its structural integrity or violate the code. It is crucial to always consult the most current edition of the National Electrical Code and local amendments for the most accurate and applicable regulations in a specific jurisdiction. There might be local regulations or interpretations that could further restrict or clarify these installation practices. Consider several important factors when installing alarm cables, especially in plenum spaces or areas above suspended ceilings. Firstly, ensure that the cable used is rated appropriately for the environment, such as being plenum rated if installed in a plenum space used for environmental air handling. Secondly, support the cable properly to prevent strain on connections and to comply with the National Electrical Code's requirements for cable support. Thirdly, avoid bundling the cable excessively, which can lead to overheating or signal degradation. Fourthly, maintain adequate separation between low-voltage alarm cables and high-voltage power conductors to prevent electrical interference and ensure safety. Fifthly, properly ground the system to minimize the risk of electrical shock and ensure reliable operation. Sixthly, secure the cable to suitable structural elements of the building, not to piping or other systems that could be subject to movement or vibration. Seventhly, use appropriate fasteners and supports that are compatible with both the cable and the building materials to which it is being attached. Eighthly, consider the accessibility of the cable for future maintenance or repairs, ensuring that it is not buried or concealed in a way that makes it difficult to access. Ninthly, document the cable routing and connections to facilitate troubleshooting and future modifications to the system. Tenthly, inspect the installation to ensure that it meets all applicable code requirements and industry best practices. Also ensure all the installation practices are in compliance with local codes and regulations. The National Electrical Code provides comprehensive guidelines for electrical installations, and local jurisdictions may have additional requirements. Always refer to the latest edition of the National Electrical Code and consult with local authorities to ensure compliance. It is also good practice to consult with a qualified electrician or fire alarm technician to ensure that the installation is performed correctly and safely. Failure to follow these guidelines can result in safety hazards, equipment damage, and code violations. Furthermore, consider the environmental conditions in the installation location. If the area is subject to moisture, temperature extremes, or corrosive substances, use cables and connectors that are specifically designed for those conditions. Protect the cables from physical damage by routing them away from areas where they could be crushed, cut, or otherwise damaged. Use conduit or other protective measures where necessary. In addition, ensure that the cable is properly labeled and identified to facilitate future maintenance and troubleshooting. Use cable markers or labels to indicate the cable's function, origin, and destination. Maintain accurate records of the cable routing and connections. Regular inspection and maintenance of the alarm system are essential to ensure its continued reliability and effectiveness. Inspect the cables, connections, and devices periodically for signs of damage, corrosion, or wear. Test the system regularly to verify that it is functioning properly. Address any issues promptly to prevent them from escalating into more serious problems. Moreover, consider the impact of the installation on the building's fire protection system. Ensure that the cable installation does not obstruct or interfere with the operation of sprinklers, smoke detectors, or other fire safety equipment. Maintain adequate clearance around these devices to allow them to function properly. Coordinate the installation with the building's fire protection engineer or contractor to ensure that it is compatible with the overall fire safety plan. It's important to note that while strapping alarm cable to sprinkler piping might be permissible under certain conditions, it is generally not recommended as a best practice. There are several reasons for this. Firstly, sprinkler piping is often subject to movement and vibration, which can damage the cable or its connections. Secondly, the weight of the cable can put stress on the sprinkler piping, potentially causing leaks or other problems. Thirdly, the presence of the cable can make it more difficult to inspect and maintain the sprinkler system. For these reasons, it is generally preferable to support the alarm cable independently of the sprinkler piping, using dedicated cable supports or hangers. This will ensure that the cable is properly supported and protected, without interfering with the operation of the sprinkler system. It is important to always consider the specific circumstances of the installation and follow the manufacturer's recommendations for cable support and installation. In addition to the above considerations, it is important to be aware of any specific requirements or restrictions that may apply to the installation of alarm cables in healthcare facilities, schools, or other sensitive environments. These facilities may have additional regulations or guidelines that must be followed to ensure patient safety, student safety, or other security concerns. Consult with the facility's management or security personnel to determine whether any specific requirements apply. Furthermore, consider the potential for future expansion or modification of the alarm system. Design the installation in a way that allows for easy addition or removal of cables as needed. Use modular components and flexible wiring methods to facilitate future changes. Maintain accurate records of the cable routing and connections to simplify future troubleshooting and modifications. Finally, it is important to stay up to date on the latest developments in electrical codes and standards. The National Electrical Code is revised every 3 years, and new technologies and installation methods are constantly emerging. Attend training courses, read industry publications, and consult with experts to stay informed about the latest changes and best practices. This will help to ensure that the alarm system is installed safely and effectively, and that it complies with all applicable requirements. In conclusion, the installation of alarm cables requires careful consideration of various factors, including the National Electrical Code requirements, local regulations, environmental conditions, and the specific circumstances of the installation. By following the guidelines outlined above and consulting with qualified professionals, it is possible to ensure that the alarm system is installed safely, effectively, and in compliance with all applicable requirements.